Okay, so nakikita nyo yung screen? White screen.
Yes, ma'am. Yes, ma'am.
Okay, so last meeting I have uploaded the lecture video regarding detention members. So I hope you have watched and read the module attached.
Dyan before?
So continuing, we will be having a problem. Example for tension members. So hindi ko pa nabigay, wala pa akong nabigay na sample problem sa inyo, di ba? Still. Fourth year. Wala pa. Okay. So I hope you have read the attached module regarding the tension members and memorize the given equations used in solving for the design and allowable tensile strength of members. Okay? So for problem, we have here problem 1. So the figure shows a 12 mm thick angle bar that is connected to a gusset plate using 4 20 mm diameter rivets. Okay, so 4 na diameter. So we have 1, 2, 3, 4. We have to determine the design and allowable tensile strength of the member. So ang kailangan natin dito is the design that is using the LRFD method, and for the allowable tensile strength that is using the ASD method. Okay? Against the yielding and rupture. We have to use a 36 steel with Fy that is equal to 248 MPa, and Fu we have 400 MPa. So that's the P. Okay? So for our solution, we have to first determine our effective hole diameter, yung DE natin. Okay? Because we will use this in the analysis using the against rupture and or fracture. Okay? Yes? Nya di ay? Wait lang. Wait lang. Ayan. Okay, balik tayo. So for the effective diameter, how to solve for the effective hole diameter? Ang kailangan natin is the DE, yan yung effective hole diameter. Okay? Ang given dito is the diameter of rivets. That is, the diameter of rivets is 20 mm. Okay? So ano yung magiging nominal hole diameter? So nominal diameter of hole, this is the nominal. Okay? So balik tayo dito sa lecture natin. Nasaan na yun? Oh, ito. For the hole. Yung given na bolt or rivet diameter natin is less than 24 mm. Okay? So yung nominal diameter of hole natin is diameter of rivet or bolt plus 2 mm. That is the nominal hole diameter. So ano yung magiging effective hole diameter natin? The effective hole diameter is equal to the diameter of bolt plus 4 mm, or the diameter of nominal hole plus 2 mm. Okay? So for the nominal diameter of hole, that is the diameter of rivet, 20 plus 2, so that is 22. Okay? So the effective diameter of hole, or the effective hole diameter, is the nominal hole plus 2 mm. Okay? So that is 22 plus 2, that is 24 mm. Or you can directly add yung diameter of rivet or hole, ito, diameter of rivet or bolt, sorry, plus 4 mm, since ang given na diameter ng rivet natin is less than 24. Okay? So plus 5 pag more than 24. So our effective hole diameter is equal to 24 mm. Okay? So unahin natin yung against yielding. So against gross yielding, section yielding. So ano yung magiging equation natin? For the LRFD, PU is equal to phi RN. Yeah, from the code. And for the ASD, yung ating PA is equal to the RN over the omega. Okay? So I hope na ma-remember nyo pa yung lecture discussion natin last week. Okay? So yung tensile strength, ito yung tensile strength natin. Design tensile strength. Ito yung ultimate load natin. Allowable. Ito yung magiging allowable tensile strength, yung Rn over omega. Okay? So ang hinahanap natin is the allowable design and the allowable tensile strength. So yung PU, that is equal to ito. Ito yung hinahanap natin, di ba? Ito din yung hinahanap natin for the allowable tensile strength. Okay? So, yung fee natin, ano yung fee natin pag gross yielding? Ano yung fee natin for gross yielding, for tension member? Ano yung value natin dito? Fee is equal to
0.9.
0.9. And then for the omega, for the ASD, ilan ito? For the gross section yielding. That is equal to
1.67.
1.67. Okay? So ang hahanapin lang natin is yung value ng Rn. Value ng Rn. Okay? Yung nominal strength natin, tensile strength. Okay? So for the gross yielding, Rn is equal to, ano yung equation natin for the Rn? For the gross yielding. Ano yung equation natin for Rn? Fy is equal to Ag. Okay, so given yung Fy kasi 836, Fy is equal to 248. Ano yung magiging area gross natin? Okay, ano yung magiging area gross natin? Yung gross width, which is 300 times the thickness of the bar. Diba? So, yan yung magiging area gross natin. So, ang magiging nominal strength natin for gross yielding is equal to 248 MPa times 300 mm times 12 mm. So, ilan ito? So, Newton mm squared, Newton na lang yung matitira. Okay?
89.2800, ma'am.
00 in Newton. Kasi naka-mm ito, naka-mm, naka-Newton per mm squared ito. Okay? So, magka-cancel yung mm squared dito, Newton na lang yung matitira. So, ito na yung magiging nominal strength natin. Nominal. So ano yung magiging design strength natin? So design strength is VRN. Ito yung kinahanap natin, di ba? Design strength against yielding. So VRN is equal to 0.9. I-multiply lang natin ito dito sa ating factor. 0.9 times 892 800 Newton. Ilan ito?
80, 35, 20, ma'am.
80, 35, 20 in Newton. Okay? And for our allowable, Rn over the omega. So Rn natin is 892, 800 over 1.67. So ano yung magiging value natin dito?
53, 46, 10.78.
53, 46, 10.78 Newton. Okay? So ito na yung magiging sagot natin sa design and allowable tensile strength of the member against yielding. So yielding lang ito, gross yielding. So ito na yung magiging sagot mo for the design and ito na yung for the allowable in Newton. Okay? Paano naman pag against the rupture or yung fracture? So the allowable tensile and the design tensile strength against rupture. Ano yung magiging pag-rupture? Ano yung magiging nominal natin? The same pa rin yung ating equation, di ba? VRN, Rn over omega pa rin yung sa ASD. This is for the design allowable. Okay? So ano yung magiging nominal natin dito for the rupture? Nominal is equal to
FU times AE.
FU times AE. So given yung FU, which is 400 MPa, ang kailangan natin is yung value ng AE. Okay? So ano yung magiging value ng AE natin? So ang equation natin ng AE, this is yung capital U, yung shear log factor times the net area. Okay? So ano yung magiging shear log factor natin na U dito? Ano yung magiging shear log factor natin? Value for the shear log factor. Because the length of the connection, yung length ng connection, pagkabalik kayo dito sa case 2, balik tayo dito. Ito, wala tayong given dito. So hindi natin ito masosolve. It cannot be solved using this case 2 since this value is not given. Okay? So anong gagamitin natin? Yung case 8. Pagkatignan nyo itong case 8. Okay? And since there are two bolts in line of the direction of the load, di ba yung bolt natin, pag ganun siya. Two bolts in line with the direction of the load, pag ganun yung load natin. Ang magiging U natin is 0.6. Okay? So this will now be our value for our shear log factor. In instances that the value of the length of the connection of the eccentricity, itong mga to, X bar and L, is given. Lalo na pag ang given is yung mga standard section, meron tayong values. Tapos pagka meron tayong L, given yung mga distances ng bolt, you can solve for this case 2. In cases na pwede nyong ma-solve yung case 2, i-compare nyo yung value doon sa nakuha nyong maybe use yung ibang shear log factor. Case 1, case 2, pagka nag-solve kayo, case 7 or case 8. Depending doon sa kung anong mai-apply na cases doon sa given sa problem. Okay? Compare yung value ng shear log factor natin, U, and then the larger value, yun yung gagamitin natin. Okay? Use the larger value. So yung magiging U natin dito is equal to 0.60. Ang kailangan na lang natin is the value of AN. So, paano natin kunin yung AN? That is the net area. Okay? So, pagka maalala nyo, pag ito, ang magiging net area natin, dito, ito yung magiging failure natin. Dadaan siya sa butas. Okay? Net section fracture. Okay, so pagka ito yung failure natin, ang net natin, ima-minus natin yung area na dinaanan natin na butas. Okay? So, ang magiging net area natin is W gross width minus the summation of DE. Ito yung effective hole diameter. Okay? So pagka staggered yan, magpa-plus kayo ng summation of S squared over 4G. And since hindi siya staggered, 0 yan. Siyempre, imumultiply natin yan ng thickness. Area ang hinahanap natin. Okay? So ano yung magiging net area natin? That is the gross width, 300 minus yung summation, dalawa yung dadaanan ng butas. So 2 times the effective hole diameter, which is 24, times the thickness, 12. So, ang magiging net area natin, ano yung magiging net area natin dito? Area N. Kindly solve for our value for AN.
3024, ma'am.
3024 mm squared. Yan yung magiging AN natin. Okay? So pagka meron na tayong net area, makukuha na natin yung effective area, which is U 0.6 times the AN 3024 mm squared. So ano na yung magiging AE natin or our effective net area? So 0.6 times 3024,
1814.4, ma'am.
18,
14.4,
14.4
ma'am.
mm squared. I forgot. Huwag nyo palang kalimutan yung ito. Huwag nyo palang kalimutan yung limit natin for the net area. Okay? This should be less than 0.85 AG. Huwag nyo kalimutan ito. Okay? So, isolve nyo muna yung 0.5 AG. 0.85 of AG. So, 0.85 times 300 times 12. Ilan yun? So, we have
30, ma'am.
0.85 times 300 times 12. Ang AG,
36.
okay, so we have 3060 mm squared. So less than yung 3024, so okay ito. So gagamitin natin 3024. In cases na mas malaki yung na-solve yung AN kaysa doon sa gross, yung 0.85 of gross, ang gagamitin ninyo is ito, yung 0.85 of area gross. Okay? So meron na tayong AE which is 1814.4. So we can now solve for the value of Rn. So ano yung magiging value natin for Rn? That is FUAE. Yung FU natin is 400 MPa. That is 400 Newton mm squared times ano yung AE natin? 1814.4. So 1814.4 mm squared. Okay, so ano yung magiging nominal strength natin, tensile strength natin for rupture, against rupture?
5760, ma'am.
72,
5760, ma'am.
5760. This is in Newton. Or you can convert this in kilonewton, 725.76 kilonewton. Okay? Ito na yung magiging nominal tensile strength natin. Nominal. Ang hinahanap natin is the design and the allowable. So ano yung magiging design natin? That is PRN. Ang alam natin, ano yung magiging value ng phi natin pagka against fracture or rupture? Net section fracture. Ano yung magiging value ng phi natin? Ano yung phi natin dito?
0.75.
0.75. Huwag kalimutan na pag against net section fracture, rupture, or fracture, 0.75 ang fee. Pagka gross yielding, pagka gross, 0.9. Okay? And for our allowable, Rn is equal to omega. Ang omega natin dito is, ilan yung omega natin value for our factor of safety? That is equal to 2.0. Net fracture. Pagka gross yielding, 1.67. Okay? Huwag kalimutan. So, given yung Rn, so 0.75 times na-solve natin, that is 725.76 kilonewton. Paki-solve yung value natin and yung Rn, 725.76 kilonewton over 2. So, ilan yung value natin for our allowable tensile strength against rupture?
544.32, ma'am.
So, we have 544.32 in kilonewton. Kilonewton yung kinuha ko. And then for the allowable tensile strength against rupture is equal to
362.88.
362.88
ma'am.
62.88 kilonewton. Okay? So, ito na yung magiging sagot natin. This is yung 544 for the design tensile strength against the net fracture. And yung 362.88, that is the allowable tensile strength against rupture. Okay? So, sa problem number 1, 4 yung hinahanap. So, ito, for the gross yielding at design and allowable. Tapos, ito, the design and allowable for tensile rupture. Okay? So, that is for the problem number 1. Okay, do you have any question before we proceed to our problem number 2? Okay, so let's have another example. Okay, so let's have another example. We have to calculate the net area along path 1, 2, 3, 4. So ito yung given. Ito, path 1, 2, 3, 4, 5, 6. For the C20 by 30 as shown in the figure, ito yung given. Okay? So the diameter of bolt is equal to 20 mm. So the properties of 230 by 30 is given here. Ito yung mga properties natin. So AG, TW, DT, WN, BF. Okay? So ang hinahanap natin is the net area along path 1, 2, 3. So net area along path 1, 2, 3. So ito yung given. So anong gagawin natin dito? Since ito yung given, yung unang gagawin natin is we have to convert our channel section into its equivalent plate for easier analysis. So, i-convert natin itong given C-section natin, channel section, into its equivalent plate. Okay? So, paano i-convert ito into its equivalent plate? Ang magiging equivalent plate niya, yan. Ganyan siya. Ito na yung magiging equivalent plate natin. Okay? So, saan kinuha yung 37.3? Saan kinuha yung 59.07? Saan kinuha yung 149? Okay? Saan kinuha ito? Paano ito? Paano na-convert? So, pagka nagko-convert kayo, huwag niyong kalimutan ito. Ito, ginawa niyong straight yan. Yung C-channel natin. Ginawa natin ganito. So, parang ito yung C-channel natin. Ito yung flange natin. Okay? So, paano yung una? Paano natin sinolve yung value ng ating 37.3? Paano natin nakuha yung 37.3? Okay? So remember, ito, di ba, yan yung value natin dyan is BF. So, ano yung value ng BF natin? Ang BF natin is 67.3, di ba? So, itong buong ito, yan, BF. So, ang BF natin, that is equal to 67.3. Okay? So, ang hinahanap natin dito, ito yung hinahanap natin doon. Ito yung magiging 37.3 natin. Itong value na ito. So, paano kunin yan? X pala. Ito na yung magiging value natin. Ito yung X natin. Ito yung hinahanap natin. So, paano natin isosolve yung X natin given yung BF natin, 67.3 minus yung 30, kaya 37.3. Okay? Kaya 37.3, yan yung 37.3 natin. Ito yan. 37.3. Eh, paano naman yung 59.05? Paano naman yung 59.05? Okay, we have 10 minutes. Paano na-solve yung 59.05? Okay? So, para ma-solve yung 69.05, ito, kunin nyo ito. Pagka kinuha nyo dito, hanggang doon sa may center lang tayo. Okay? Hanggang dito sa may kalahati nung web. Center to center. Okay? So, center dito, tapos center dito sa bolt. Yun yung kukunin ninyo. Plus, yung value dito. From the center of the flange, papunta dito sa next bolt. Yan. So, say this is A, this is B. So, A plus B, yan yung 59.05. So, ilan yun? So, we have 30. So, we have 30 minus yung thickness ng flange natin. Yung thickness ng flange is equal to 10.5. Tapos, yung thickness ng web is 11.2. 11.4. Okay? So, 30 minus yung thickness ng web. Ano yung thickness ng web? So, 30 minus thickness ng web, 11.4. So, 11.4 over 2. Tapos, yung isa, yung ito, yung value dito, that is 40 mula dito. So, 40 minus the thickness of the flange. Thickness of the flange is equal to 10.5 over 2. Kasi dito sa kalahati. So, 10.5 over 2. So, pakisolve ito. This is 24.3. And this is equal to 10.5 over 2. 40 minus 10.5 over 2. This is 34.75. So, kindly check pagkatama. So, pagka inad nyo yung dalawa, magiging 59.05. Okay? Kaya yan yung 59.05. So, yung bolt dito sa 2, ito yung 2 kasi natin, ito yung 3. Okay? Yung distance dyan, yan, pagka ginawa mong straight yan, ang distance dyan is 59.05. Kaya yung bolt 2 from 3 is 59.05. Okay? So, the same siya dito sa 5, 6, 4, 5. The same siya dito sa 1, 2, 2, 3. Kaya parehas sa 37.3, 59.05. Okay? The same na 4D. Pagkaiba yung distances, isolve mo yung distances niya. Okay? So, since parehas yung 59.05 and 37.3. O, paano naman kinuha yung 149? So, ito, yung buong ito, di ba yan yung ating depth, 229. So, 229 minus 2 na dalawang 40, kaya ang kalalabasan niya is 149. Okay, so yung 149 natin dito is equal to 229 minus 2 times 40. Yan yung 149. Okay? So ito yung unang step natin to convert our channel section into its equivalent plate. So pagka kinonvert natin yan, yan yung magiging equivalent plate niya with the distances. Okay? So mas madali na lang kunin. Yung kukunin natin is yung net area along path 1, 2, 3, 4, 5, and 6. So yan yung hinahanap natin sa problem natin. Ito. To calculate the net area along path 1, 2, 3, 4, 5, 6. Okay? Okay? So pagka tinitignan natin ito, magiging staggered, di ba? Magiging staggered na yung ating failure. Okay? So yung hinahanap natin is the net area. So net area is equal to the net width times the thickness. Okay? So yung AN natin is equal to the area gross, since given yung area gross natin. Area gross given, di ba? Pwedeng ito, pagka given yung thickness, net width, or pwedeng yung net area natin is just the area gross. Huwag nating i-multiply ng thickness, area gross, minus the summation of DE times the thickness plus the summation of S squared over 4G times thickness. Siyempre, area ang hinahanap natin. Okay? Staggered, kaya meron tayong S squared over 4G. Area gross given. So, yung net width natin, net area natin is the area gross. Ilan yung area gross natin? 3,790. So, we have 3,790 minus, okay, summation of DE. Ano pala yung magiging effective hole diameter natin? Diameter of bolt is 20 mm. Ano yung magiging DE natin?
24, ma'am.
We have 24 mm. Okay? Yung DE natin is the hole diameter plus 2 mm. Ang hole diameter natin is the diameter of bolt plus 2 mm. Okay? Kaya 24 yung DE natin. Okay? So, we have, ilan ang bolt natin? Dalawa. Di ba? Ito. Ang thickness natin, dalawa sa 10.5, di ba? Ito yung isang, andito, yung isang bolt natin, andito yung isang bolt natin. Dalawa na ang thickness, 10.5. And then, dalawa na ang thickness is yung thickness ng web, which is 11.4. So, dalawa ding na bolt ang nasa 11.4. Okay? So, yung summation of DE times T, so dalawa, DE 24 times T, dalawa sa may flange, 10.5 yung thickness ng flange, dalawa din sa may web. So, yung DE 24 times yung thickness ng web, 11.4. So, ito, yan. Ito yan. Equivalent niya. Okay? Ang problema na lang natin is yung sa may staggered. Yung S is S squared over 4G. So, i-add natin. Okay. So, unahin natin itong ito. S. Ito, S. Diba? Ito yung S natin. Pagka ito yung P natin. Ito yung S natin. 40. 40. Yung G natin. Yung G. 4G. So, say unahin natin ito. Ba? Ito 3, 4. Pwede. Pwede ito. 3, 4. Kaya yung G natin is 149. Unahin natin. 3, 4. Kaya yung ano natin dyan, yung S squared over 4G natin is 40 squared over 4 times, ang distance natin dyan is 149 times yung thickness natin. Ano yung magiging thickness natin? Ito, nasa web. So, yung thickness ng web, yun yung kukunin natin, which is 11.4. Okay? Plus, ano pa? Ano pa yung magiging value natin dito? Ito, yung 2 to 3, ito ding dalawa. Diba? Yan, yung distance ng bolt 2 to 3 and 4 to 5. Yung kinuha natin dito, yung 149, ito, distance ng 2 to 3. Ito, 2 to 3, 3 to 4 na bolt. Okay? Ang isa pa, yung naka-staggered, yung 2 to 3, and then yung 4 to 5. So, parehas lang yung distance niya dito, kaya times 2. Okay? So, 2, dalawang beses. Kasi isa dito, 2 to 3, 4 to 5. Parehas lang kasi ng distance na 59, yung G distance, yung gauge distance. Okay? Ano yung magiging S natin? Ang S natin, ano yung magiging S natin? 40 pa rin. So, 40 squared over 4 times, ano yung magiging G natin? This is 59 point. So, we have 40 squared, that is our S. G natin, gauge, 59.05. That is S squared over 4G. Times 2 kasi dalawa. Ano yung magiging thickness natin dito? Ano yung magiging thickness natin dito? Okay? Ito, half ang kinuha niya, nasa flange. Diba? Nasa flange yung iba, nasa web yung iba. Pati din dito sa 59.05. So ano yung magiging thickness natin? I-average lang natin yung thickness ng flange and yung thickness ng web natin. Kasi ito, meron siyang nakuha na thickness ng flange. Meron din dito. Thickness ng flange, thickness ng web. So i-average natin yung thickness, yun yung magiging thickness natin dito sa equation. So that is 10.5 plus 11.4 over 2. Okay? So yan yung magiging thickness natin for the staggered bolt 2, 3, tapos 4, 5. Okay? So yan na. Ito, yung bolt sa 2, 3, and 4, 5. Okay? So kompleto na yung value natin sa ating equation. So paki-solve ito. So we have AN. We have 3,790 minus 2 times 24 times 10.5. That is equal to 504 minus 2 times 24 times 11.4. 547.2 plus, so paki-check pag tama yung aking calculation. So ito, 30.604 plus 40 squared over 4 times 69.04 times 10.5 over. This is plus 148.374. So ano yung magiging value ng AN natin? AN is equal to
2917.778, ma'am.
So 2917.778
778, ma'am.
in mm square. So ito na yung sagot natin for problem number 2. Okay, so let's solve for problem number 3. So we have to determine the tensile design strength and the allowable tensile design strength against rupture for the 400 by 20 mm steel plate when loaded in tension as shown in the figure below. So we have here our figure. So we have to assume that our FU is equal to 400 MPa and that all holes have a nominal or gross diameter equal to 23 mm. m. Okay, so ang given dito is the nominal or gross diameter of hole, which is equal to 23 mm. Okay? So our required here is we have to solve the tensile strength against rupture. So against rupture. So we have here, in the figure, we have here a staggered hole. So gagamitin natin yung Cochrane equation in solving for the net area. Okay? So our effective diameter, DE, is equal to the hole diameter, the diameter of hole, plus 2 mm. So since this is 23, yung nominal hole diameter natin is 23. That is less than 24, kaya plus 2 mm. So this is equal to 25 mm. Okay? So to solve for the design and allowable tensile strength, we should know, or we should solve first our Rn, or yung nominal strength. Okay? Since this is used to solve for our tensile design strength and the allowable tensile strength. Tensile strength. Okay? So, our design strength is equal to, yung design strength natin, equal to phi Rn. Our phi is equal to, this is against rupture, so our phi is equal to 0.75. So, we need to solve our Rn. Okay? And for the allowable tensile strength, this is equal to Rn over omega. Our value for omega for tension members against rupture is equal to 2.0. Of course, we need to solve the value of Rn. Okay? So, solving for the Rn. So Rn, or the nominal strength, is equal to FUAE. Okay? FUAE. So yung AE natin, since this is plate, U times AN. Okay? 1.0, kaya this is equivalent to FU times AN. 1.0, 100%. Okay? So FUAN or FUAE, our shear lag factor U is 1.0. Okay? So FU is given 400 MPa. We need to solve the value of our AN. Okay? So our AN is equal to the W gross minus the summation of the effective diameter, DE, plus the summation of S squared over 4G. That is for the staggered times, of course, the thickness. Okay? So in the figure, we have here a different path of failure. So kailangan natin kunin lahat ng path of failure to determine our critical net area. Okay? So pwedeng yung failure ng ating plate is from 1, 2, 3, tapos puntang 4, 5, or 6. Pwedeng ganyan yung failure niya. Pwede din ang failure natin is ito, 1, 2, puntang 3, tapos puntang 5, and puntang 6. Or pwede din ang failure natin is 1, 2, 5, 6. Pwedeng ganyan din yung failure natin. So, kailangan natin kunin lahat yung net area in each path of failure to determine our critical net area. Okay? So, let's say for path 1, 2, 3, 4, 5, 6. For path 1, 2, 3, 4, 5, 6. Our AN is equal to, the gross width is equal to 400. Sabi nito 400 by 20. So, ang gross width natin is 400. So, minus the effective hole diameter, the summation of effective hole diameter. So, ito, pagka path 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Ilang butas yung dadaanan ng failure? 4. Diba? So, that is 4 times the effective diameter, which is 25. Okay? Plus, ito, dito na tayo sa staggered. So, sa path 1, 2, 3, 4, 5, and 6, yung 2, 3 staggered, yung 3, 4 staggered, yung 4, 5 staggered. Okay? So, pagka tinitignan natin, yung 2, 3, tsaka 3, 4, parehas yung S niya, 40, parehas yung G niya, yung gauge niya, 100. So, pwede mong isulat, ito, 2 times S 40 squared over 4 times 100, yung G. Okay? Plus, ano pa yung isa? We have to add yung bolt 4 and 5. Diba? Yung bolt 4 and 5. Wait. So, you have to add this, bolt 4 to 5. Ang S natin is 70. Ang G natin is 100. So, 70 squared over 4 times 100. Okay? So, yan. Isa lang. Ito. Ito yung dalawa, kaya times 2. Isa lang ito, kaya walang times. Squared ito. Times our thickness, which is 20 mm. So, ilan ito? Ang value natin dito is 6405 mm squared. Okay? That is for path 1, 2, 3, 4, 5, and 6. So, another path. Let's take path 1, 2, 3, 5, and 6. So, our net area, gross width natin is 400 minus ilan yung dadaanan ng butas pag ang path failure natin is 1, 2, 3, 5, and 6. So, tatlo. So, 3 times 25. So, plus, we have 40 squared over 4 times 100. That is for 2, 3. Tapos yung 3, 5, that is plus 30 squared over 4 times 200. Okay? So, bakit 30? Remember, ito, 4, 5 is 70. Tapos, 3, 2 is 40. 3, 4 is 40. So, 70 minus 40, ang S natin dito is 30. So, 30 times 200, ang gauge natin is from 3 hanggang dito sa 5. 100 plus 100, that is 200. Okay? So, times 20. So, yung magiging net area natin dito is equal to 6602.5 mm squared. Okay? And for our last path 1, 2, 5, 6. Okay? For our net area, that is equal to gross width 400 minus dalawa lang yung dadaanan niyang butas, so times 25 plus 10 squared over 4 times 300. Bakit 300? Yung ito, 2 papuntang 5, 'di ba? Ito lang yung pag ito yung path natin, ito yung mag-i-staggered whole 2 and 5. Bakit 10? Okay. So remember, this is 70 from dito 70 yan hanggang 5. Ito from 4 hanggang 2 80 yan. So 80 minus 70 10. So 10 yung magiging S natin and 300 yung magiging gauge natin. So this is 300. So 100 times 3, 300 kaya 300. Times 20. So that would result to 7,001.6 mm squared. So ito yung magiging net area natin sa part 1, 2, 5, 6. So considering these three paths, ano yung magiging critical net area natin? Therefore, ang critical net area natin is the lowest area, yung 6405 mm squared. Okay? So pagka kinuha kasi natin yung 7,001.6, hindi nga siya mag-fail ng path 1, 1, 2, 5, 6. Mag-fail naman siya sa path 1, 2, 3, 4, 5, and 6. Okay? So the lowest is the critical net area. So ang magiging AN na natin is equal to 6405 mm squared. Okay? So kanina, solving for the RNFU AE, this is 1.0 AN. So we have FU natin is 400 MPa, that is Newton mm squared, times yung AN natin is 6505 mm squared. So this would result to 2562 kilonewton. That is our nominal strength. Okay? Ang hinahanap natin is the design and the allowable strength. Sabi natin, ang design strength, this is our design strength, that is equal to 0.75 times 2562 Rn is equal to 1921.5 kilonewton. And for our allowable, that is 2562 kilonewton over 2.0 equal to 1281 kilonewton. So this is our design strength, tensile strength, and this is our allowable tensile strength. So ito yung magiging sagot natin for the problem number 2. Okay?